Hello, welcome to Maths with EJD. This is the second video on graph and network theory, right? And in the first video, I talked about introduction to graphs, where we looked at the definition of a graph. We looked that it is a collection of vertices and edges, right? Then we went ahead to look at types of graphs, some special graphs, and how graphs are represented using adjacency list, adjacency matrix, and incidence matrix, right? So here I want to show you the Python library. I want to show you how to represent those graphs, how to plot those networks and graphs, right? Um, of course, you remember the types of graphs. We have complete graph, which is like a K4 graph. If it has a fully connected graph with four nodes where every node is adjacent to every other side, that's one of the graphs we'll be representing here. Then I'll also be showing you a bipartite graph, which is a graph with two sets of nodes, U1, U2, and V1, V2, where edges only connect nodes from different sets. Then you have a cycle graph, a graph forming a closed loop of four nodes where each node is connected to two other nodes in a cycle. We are not saying that the cycle graph is always four nodes. No, it can be more than that. But the ones I'm showing you here, that's what I'm referring to. Then here I'm talking about we're looking at a directed graph too. That's a graph with directed edges showing a flow from node to node in a specific direction. So there's arrow to show where a particular node is leading to. Then you have a tree graph, which is a hierarchical graph with no cycles, where nodes are connected in a branching structure. And then you have a star graph, which is a graph with one central node connected to multiple leaf nodes, resembling a star shape. So, in computer networking, right, there's this whole thing about networking topology and all that. So graphs have something to do with all of that kind of connectivity. So now let's look at the Python codes for these things I've described already. So if you see, okay, I think it's always good to show the line numbers so I can refer to line numbers. So you see Python codes for graphs, right? In the first line, we're plotting matplotlib.pyplot as PLT because matplotlib is what we use in showing graphs. But when I mean graph, in showing plots, I think that's a better word to use. So you want to actually see the plots like that. Then line two is where we're importing the network X as NX. Network X is actually the special library for representing networks in Python, right? So in line four, right, we'll create a canvas for multiple diagrams because I want a 2 by 3, I want two rows and three columns. I want because there are six things I want to show from already what you've seen. Complete bipartite cycle, directed, tree, and star. So those are the six things. So I create a canvas, a 2 by 3 canvas, two rows, three columns, like that. And then this is where we get to define the six graphs. Okay. So the first one is you have G1. G1 is actually nx.complete underscore graph with four nodes, right? Um, if you, after this, I may want to also try maybe change the number for you to see what happens like that. Then we can learn from that. So you have G1, that's a complete graph. Then G2 is actually a bipartite graph. So here we just say nx.graph, and that's all that is. So that for G2 now you declare the nx.graph. Then you now say that G2 dot add edges. You don't want to add the edges because the edges are not fixed. So maybe you want it to be U1 V1. So you have power over this U1 V1, U1 V2, and all of that. And that is a bipartite graph. Then G3 now, G3 you just say nx.graph. So you can now add. So if you want to add edges, you define the graph first. Then you can now add the edges. G3 add edges from 0, 1, 1 to 2, 3, 3, 0, and that will be like a cycle graph. Then you can also, so that's a normal graph. But what if you want a directed graph? So so you can see there are two types now, undirected graph and directed graph. So if you want to do a directed graph, you just say graph. You just use nx.graph. But if you want a directed graph, you use nx.digraph, like what we have in line 14. So actually, maybe to separate these things, so you can see that, you know, what what is now line 11 and 12, they are together. So with G2, first of all, you define the G2, then line 12 is where you add the edges as you wish. You can change the edges to suit what you want to achieve. Then here too we have G3 in line 14, NX.graph, then you add the edges 0, 1, 1, 2. Then of course you have to pay attention to how it actually flows. You have a full bracket, then followed by a square, a parenthesis, I think that's a better word, then followed by a square bracket. Then you now have pairs of your edges in the bracket separated by commas. And then if you want a diagraph, you don't just do nx.graph. You say nx.diagraph now. So for this diagraph, it means that the lines will be drawn with arrows to show the direction in which the edges are flowing. So you have nx.diagraph, and then you now have g4.add edges from. So you now have all the edges. So you can experiment with this and just switch these things around. So, but you see that for complete graph, you don't even have to worry. You just give it the dimension it should follow, right? Then for G5 now, so it's a graph again, not a diagraph. So you have add the edges the way you want it. Then you have the star graph also. For star graph, it's also you don't also need to define it ahead of time. So because a star graph is a standard something that can be plotted. So from lines 26 to 42, that's where you're now actually getting to draw those graphs. So you have from lines 9 to 23, that's where you define the graphs, but then you draw them from 26 to 42. So to draw the first graph now, which is actually a complete graph, so you say nx.draw, then you bring, so the G1 you have defined up there in line 9, so you can now bring it here. So you now say do you want it labeled true? If you don't want it labeled, then you can put false. Then the axis 0, node color. So now, because we have we declared 2 by 3, which is 6, right? So the args will be the first one 0, 1, 2, 3, 4, 5, 6. So you label them like that so they can occupy the different positions in your grid. In the canvas, 2 by 3 canvas, you have defined ahead. Then if you can also choose the color you want it to have, like light blue. Then the font weight, so you can decide that. Then for the second one, right, you can have more conditions like bipartite layouts and things like that. Then of course you can label complete graph K4 blah blah blah. Then of course the directed graph. So you just bring a G4. What color do you want it to have? The arrows true because you want it's a directed graph. You want arrows. Then layout. What kind of layout do you want it to have? And all that. You can sit down with it and tweak each and every of the corners. So I'm running it now. So nice. Voila, we have the graphs 2 by 3, 2 rows, 3 columns. So this is the complete graph. This is the bipartite graph. This is the cycle graph. This is the directed graph. This is the star graph. I mean the tree graph, and then this is the star graph. Guess I have to move this over here so you can see clearly. Okay, so we have all this. So I actually gave some examples of things like this previously in the other video. Okay, so we have this. So talking about types of graphs now, types of graphs. So we talk about graph matrices, I mean types of graph matrices. When we talk about representation of graphs, right, we talked about adjacency list, adjacency matrix, and incidence matrix. But so here I'm just representing these two matrices now, and I call them graph matrices. So you have the adjacency matrix, which is a square matrix representing the connections between nodes in a graph, where one indicates an edge between the nodes and zero indicates no edge. So if there's an edge between nodes A and B, then in the matrix it will be 1. All right. If there's no edge, that will be 0. In the other case of incidence matrix, it's a matrix representing the relationship between vertices and edges in a graph, where rows represent vertices and columns represent edges. So the rows are vertices, while okay, I think when I represented the other time, I just did the same thing. So I think that was wrong. So it should have been A, B, um, maybe I think I'll get opportunity to actually do it better in subsequent videos. So the rows represent vertices and the columns represent edges, with a 1 indicating that a vertex is incident to an edge and the O is indicating it is not. So we'll have opportunity to do that better in subsequent videos for sure. All right. So Python code for graph matrices now. So you have all this. Imagine Okay, of course, matplotlib network as NX, and then you create a canvas for two diagrams. Here we have just one row, two columns because we just have an adjacency matrix and an incidence matrix. So here you define the matrix, literally what you had there, 0, 1, 1, 1, 0, 1, 0, 0, 1. Of course, you can actually get this from a graph. It simply means that if you have a four by four, a four vertex graph, so to speak, and they are all joined together. So any two parts that are joined together, you put one, you know, anyone that is not joined by an edge, you put zero. And that's literally what we have here. So here, because we have two now, so you can see the vertex is 0, 0 all through here for the first one. For the incidence matrix, it's 1, 1 all through. Then all these other things are, uh, of course, this adjacency matrix you declare there, you can also, so you just bring it here for presentation. Then you have a C map, like a color map for it. It can be grays, and there are other color maps you can have. You can tweak that, like I remember there's rainbows, so to speak. There is cool, warm, and things like that. We can just do that. Then interpolation none. You have then you label it, and then the range, the length of the adjacent matrix, and things like that for the X ticks and Y ticks. The same kind of thing goes for the incidence matrix. So the key thing is just to declare the matrix. So then you want to show all of this. So you run that, and it gives you. So you see the adjacency matrix. So here now, Python numbers from zero to from zero upwards. So normally this is like A, row B, row C, row D. All right. Or better still, this is like um vertex A, vertex B, vertex C, vertex D. But now it has been labeled 0 to 3, which is okay. Then of course you also have vertex A, B, C, D, like that also. And then you have these representations. Uh Okay, so you have this for the adjacency matrix, and you have this for the incidence matrix. So the rows, just like you had, we have there, the rows for adjacency, for the incidence matrix, right? The rows represent vertices and the columns represent edges. So these rows now, vertex A, vertex B, vertex C, vertex D. The edges like this, edge AB, edge AC, edge maybe BC and all that, like that. And that is what this actually looks like. Of course, like I said the other time, you can actually tweak the color maps. What if I can say this is like rainbow, and this is cool warm. Okay, this I think I remember this much. Cool warm. I hope it works. If it doesn't work, we'll try other ones. Yeah, I mean, see how that goes. So it can be this beautiful, right? So we can have the black and white theme. Okay, in fact, let me just copy this. Let me take this back to what it was, and then, run this and then bring it back, copy this, and just I mean, you can tweak the colors. This is like what I call rainbow now, and then this is rainbow, and this is cool one. I'm trying to remember other ones. There is Viridis. Yeah, let me do Viridis here. There's Viridis. I think there's also CVDs. Yeah, something like this. So it can be this beautiful. So I mean, it borders on artwork even. So it's so sweet, right? It borders on some kind of artwork. I mean, there are many other color maps that can be used. Let me also play with one or two. So that first one we used was grays, right? We can have blues. Let me try blues and greens. Blues, blues, and then this is greens. Okay, greens. So there are so many of them. I mean, you can just Google to find out the possible color maps available. Okay, these are not working. Okay, so that's fine then. I'll just, oh, okay. I wrote blues instead of blues. Sorry, it's blues, not blues. Yeah, I mean, it's fine. So something like this works still. But I mean, this is really colorful and beautiful. So maybe you have found a new way to do some kind of artistic stuff using networks. So that is how that has been. So pardon me for that. What's that now? The the incidence matrix. I didn't quite explain that well, but I'm going to make that good as we move on in this series. So if you have not subscribed to this channel, there's in the next video I'll be talking about graph properties. And of course, also going to do Python code to represent some of these graph properties. So watch out for this. Subscribe to this channel right away so that you can keep abreast of these things and dishing out, so to speak. And then of course hit the notification bell so you can always get alerted. Comment, let me know if you want me to teach a topic or solve a problem. Like and share so that more people can have access to this great learning till I come your way again. Keep connecting, keep networking. Bye.